or in compare with other protocols, we can replace the failed pass. Okay, this is the process of the EIGRP pass metric calculation in the classic EIGRP. Don't forget, until now, we have learned about the parameters of one interface: bandwidth, load, delay, reliability. Also, we have learned about the EIGRP classic metric formula and also the roles and the functions of the metric weights. You know that with the metric weight command, you can tune these metrics, and because in the neighborship video, I have explained the configuration of the K1 to K5, but it is better to don't configure these values. In most cases, we don't want to configure them or change them. Because of that, with the default values, this formula converted to this formula. Okay, and now with the update, with the sending updates, now we can easily calculate the metric. Also, let me to give you to inform you about some of the terminology that we have in the EIGRP. For example, this pass, the best pass, is the successor pass. Okay, we call it the successor pass. What is the successor pass? Successor pass is the pass with the best pass. Actually, the successor pass is the only pass that is residing in both topology table and also the routing table. Look at here, in the show IP EIGRP topology, you can see we have one successor, and this is the successor pass. Why? Because this pass has the lower bandwidth. Also, maybe you encounter with another term, the successor. The successor can be considered the pass, or maybe in some cases we are calling the router 2 the successor of the 10400/24 for router 1, because this is the router that we can use it for reaching to the 10400. Actually, R1 considers the R2 as the successor router for reaching to the 10400. It is not so important. The important thing is that the successor pass or the successor is the best pass. That's it. This is the pass that we have on the topology table and also on the routing table. Other non-successor pass are only residing in the topology table, not in the routing table. They can, okay, they may replace or for example are injecting into the routing table when the successor fails. The next things that you should know about is the metric of the successor. This is the metric of successor. You know that for each pass we have a metric, but the metric of successor is calling the FD, or feasible distance. This is the feasible distance, the distance that we can use it. Let me to show you. Actually, the feasible distance is the metric that you can see in the routing table. Look at here. This is the metric of the best pass. This is the metric of non-successor pass. This is the metric of the successor pass. This is the metric of the non-successor pass. As you can see, FD, or feasible distance, is this value. Also in the routing table, you can see this value. Show IP route here. As you can see, this is the feasible distance. Actually, the feasible distance is metric. This is another term for EIGRP. Okay. Until now, we have learned two terms, okay, about the EIGRP. The first term is the feasible, or this, for example, successor, okay. We will use them in these parameters in future. The successor pass, the best pass, and also the successor, the router that we are using it, okay. This is the successor, the next term. And after that, we have learned about the FD, or the feasible distance. Okay, so easy and so also interesting. I know that here maybe you need to more think to, for example, think other parameters. Yes, it is okay. You can stop the video and think about all of these parameters. You can verify them. Also, here we are using only one network. For all networks here, this is happening. For example, for the 10240/24, the router 2 should send it to the router 1. Also, to the router 4 should send it to router 1. Okay, you can calculate for this, for example, parameters for all of them. Because of that, the mechanism is same, but for the different networks, we have different values. All right, until now we have learned about the EIGRP classic metric. Now I am going to talk about the EIGRP white metric. The first thing that we should know is that why we need to use the white metric. Let me first introduce some of the features now we have learned about them, and after that we can talk about the white metric. You know that when we are configuring the EIGRP with the AS number, means the classic configuration, okay, we are using router EIGRP, okay, then one AS number. Actually, when you are using this method, you have some commands under the router EIGRP and some other command on the interface. For example, for configuring the hello interval, hold time, we should configure the parameters on the interface. But when you are using the router EIGRP name, okay, it means the named mode of configuration, everything should be configured under the router EIGRP. Because of that, the method of the configuration of EIGRP with name is a more efficient method. This is the first benefits of the configuration of the EIGRP with the named mode. But beside of this benefit, we have also other benefits. For example, in this method, in the method of the, for example, named mode, we have more options, we have more efficient options, because you know that this is the newer method. For example, you know that we have the type of authentication with the SHA 256 bits in the router EIGRP name, but in the router EIGRP AS number we don't have this option. Okay, this means that the router EIGRP named or the named mode EIGRP is not only a more efficient method of configuration. In this method, we have more options, newer options, and more efficient options, okay? Because of that, one of the more efficient options that we have in the router EIGRP is the white metric. I will talk about the white metric and you will learn it, but let me to say that when you are configuring the router EIGRP AS number, actually you are using the classic metric. Classic metric, okay, is efficient method. I'm not going to say that the classic metric is not a good method or efficient method, but let me to say that in the router EIGRP name, we are using the next method of the metric calculation. We call it the white metric. White metric is a newer method and also is a more efficient method. And here we are learning about the white metric. You know that actually in compare with the in compare of the router EIGRP AS number and router EIGRP name, okay, we have some differences. The first difference is related to the more efficient method of configuration in the named mode, and the second benefits of the router EIGRP named or named mode EIGRP is the more efficient features, more efficient methods, and some other things related to the efficiency of this method. One of them is the white metric. Now, first, we should understand why the white metric is more efficient than the classic metric. After that, we can talk about the detail of the white metric. It is important to learn everything completely and also with all details. Okay, let me to talk about first the classic metric. Why? Because we should know what is the disadvantage, what is the shortcoming of the classic metric. You have learned about the classic metric. You know that the complete formula of the classic metric is this metric, is this formula, okay? And you have learned about it. As you can see here, we have some parameters such as the, for example, bandwidth, and then load, and then delay, and then reliability, that we can enable them, okay, with the key values in the formula of the EIGRP classic metric calculation. And you have learned how we are calculating the metric. We have seen some scenarios, some, for example, calculation about this. Okay, let me to review here. The first thing that I'm going to talk about the more efficiency of the white metric is related to the higher bandwidth that today's in the WANs we have. You know that EIGRP was created, okay, in the for example 2000 or maybe 1998, 1999, and some, and for example old years. In that days, okay, the bandwidth of the WAN was limited to smaller values, but now in the WANs we have more for example, bandwidth. Also, EIGRP can be used in the enterprises, such as the data centers, such as some other places that here now we have more bandwidth. Maybe you ask me, okay, what is the problem of the more bandwidth? Let me to explain it. Look at here. Here we have a simple table. As you can see here, we have some interface types. For example, the serial interface. This is not the serial that you have seen in the, for example, GNS3. This is another type of serial, because here we have the 64 kilobit per second. You know that the serial interfaces that we have in the, for example, GNS3 is using the T1. Okay, serial type. Because of that, the link speed or the bandwidth of that interface is 1544 kilobit per second. You have seen it. Also, we have Ethernet interface. Ethernet means 10 megabit per second or 10,000 kilobit per second. Fast Ethernet, 100,000 kilobit per second. Gigabit Ethernet, 1 million link speed or 1 million kilobit per second. Okay, means the 1 gigabit per second. 1 million kilo means 1 gigabit per second. Also, 10 gigabit Ethernet means 10 gigabit per second. Okay. Until now, we know that we have different type of interfaces with different bandwidths in one router and in one network. Now let me to calculate for these types for example, the first term. You know that for the metric calculation of the EIGRP in classic metric, okay, we are using this formula, and with the default values of the K1, K2, K3, K4 and K5, this formula is converting to this, for example, metric